Welcome everyone to the 8th International Scientific Conference on Contemporary Trends and Innovations in the Textile Industry. I am Ms. Pavitra Shen GT from Sana College of Technology, India, presenting alongside Dr. Subrata Das from Baneri Aman Institute of Technology, India. Our topic is Development and Characterization of Herbal-Finished Banana/Cotton Blended Fabric for Sustainable Yoga Mats. Clothing and apparel products are the foremost essential need for every human being, serving both basic protection and personal expression. The widespread use of synthetic fibers, chemical dyes, and various textile processing agents has proven to be toxic not only for human health but also for ecosystems. As a response to these challenges, we focus on herbal processes for pre-treatment, dyeing, and printing, and also carefully select fibers that do not pose risks to human or environmental health. By pursuing these approaches, the aim is to create products that respect both ecological integrity and human well-being, demonstrating a viable path for a greener textile future. The aim of our project is to develop a yoga mat made using blended banana and cotton fiber. We spin yarns in 2 different blend ratios, weave them into fabric, treat the fabric with natural soapnet, dye it with madder root, and print it using herbal extracts from neem and tulsi. We evaluate both physical and comfort properties to ensure performance and sustainability. Our objectives are: to study and source banana and cotton fibers, to develop banana/cotton blended yarns, to weave fabric from these blends, to dye and print with sustainable herbal agents, to analyze properties at each stage, to manufacture the final sustainable yoga mat. Banana fiber is a strong, eco-friendly natural fiber obtained from the pseudostem of the banana plant, which is usually an agricultural waste product. For this research, enzyme-treated banana fiber was sourced from the National Research Centre for Banana in India, ensuring quality and consistency. Cotton fiber, renowned for its softness, comfort, and high cellulose purity, was sourced from established cotton mills in India. These 2 fibers were chosen for their sustainability, availability, and complementary properties for use in blended yarns. In our herbal finishing, neem leaf powder is used for its medicinal and antibacterial qualities. Tulsi powder not only provides stress reduction and enhanced metabolic benefits while eating but also imparts a natural, soothing aroma that promotes calmness and relaxation. Tamarind seed powder functions as our thickener and fixer in printing, while also offering health benefits. Banana stem ash water, sourced from Kerala, acts as a metamordant to improve dyeing performance and color fastness of the fabric. The project focused on creating sustainable yoga mats using blended banana and cotton fibers. Yarns were spun in controlled ratios, 40:60 and 50:50, and woven into fabrics for evaluation. Eco-friendly pre-treatment, natural dyeing with madder, and herbal printing using neem, tulsi, and tamarind produced antimicrobial, durable surfaces. The final mats met ergonomic standards through testing for strength, breathability, and color fastness, proving the eco-friendly potential of herbal-finished banana/cotton yoga mats. The yarn spinning process involved blending banana and cotton fibers in defined ratios, 40:60 and 50:50, to produce yarns with desired characteristics. Using open-end spinning techniques, the fibers were aligned and twisted to form strong, uniform yarns with controlled yarn count and twist per inch. The blended yarns were woven into fabrics using 2 blend ratios, B40C60, banana 40%, cotton 60%, and B50C50, banana 50%, cotton 50%. Both fabric constructions featured 25 ends per inch and 19 picks per inch, supporting the necessary strength and comfort for yoga mat application. The woven fabrics underwent a natural pre-treatment using soapnet, effectively removing any residual natural impurities and preparing the material for optimal dye uptake and finish quality. For dyeing, madder root was chosen for its rich natural color and safety. The dye was prepared by soaking and boiling madder, and filtering to make a dye solution. The dyeing parameters included a 60-minute duration, 80–90 degrees C bath temperature, a material to liquor ratio of 150, 50% dye concentration by fabric weight, 20 grams per liter ash water as mordant, and pH between 10 and 11. After dyeing, a cold wash removed any unreacted dye. The prepared solution using madder was used to dye pre-treated fabric samples. This fully natural process ensured vibrant coloration while maintaining environmental safety, free from toxic effluent. Here we present a sample of the resulting dyed fabric, demonstrating the effectiveness of our natural dyeing method and showing a rich, uniform color suitable for yoga mat aesthetics. For printing, easily available homemade natural dyes from neem and tulsi leaves were used. Tamarind kernel seed powder acted as a thickening agent. Banana stem ash water as a mordant improved the print's binding and color fastness to rubbing and washing. All components used are safe for human contact and non-toxic to the environment. The print paste was prepared with 4 grams of tamarind seed powder, thickener, 15 grams of ash water, binder, and 81 grams of herbal dye extract, making 100 grams in total. This combination provided optimal viscosity and bonding for even herbal printing. The prepared printing paste was applied to the fabric using screen printing technique. This sustainable approach ensured safe, vivid herbal prints and minimized environmental impact. This slide showcases the naturally printed fabric sample using the B40C60 blend B50C50 blend. The results demonstrate visually appealing patterns and effective coloration using neem and tulsi herbal extracts. Coming to the results and discussion part, for both blend ratios, yarns produced had a count of 12s, 36 twists per inch, and S-direction twist. This ensures mechanical consistency between samples for a fair comparison of further properties. Results show that the B40C60 blend has superior tensile strength compared to B50C50, confirmed by a highly significant t-test, p-value equals 0.0000000014. This supports the mechanical reliability of the B40C60 blend for yoga mats. Similarly, elongation is better in B40C60 yarn than in B50C50, again with strong statistical significance, p-value equals 0.00000075. This suggests improved flexibility and durability for the yoga mat. This slide presents higher GSM, thickness, and stiffness for the B40C60 blend compared to the B50C50 blend, supporting its suitability for yoga mats where support and cushioning are required. However, tearing strength is better in the B50C50 blend for both warp and weft directions, with highly significant test results. This provides a meaningful comparison between blends for durability under stress. B50C50 fabric shows higher air permeability than B40C60, indicated by significant statistical difference, suggesting better breathability and user comfort. Water vapor permeability, again higher in the B50C50 blend, is crucial for moisture management during yoga practice, contributing to a pleasant user experience. Colorimetric analysis reveals that both blends have similar L, A, B, C, and H asterisk values, with B50C50 showing a marginally higher K/S value, suggesting slightly deeper color for market appeal. Color fastness testing shows both blend samples achieve grades above 4 for dyed and printed fabric, satisfying industry standards for durability against rubbing and washing. Here you see the finished sustainable fabric developed for yoga mats. Its physical and aesthetic properties meet the requirements for healthy, eco-conscious yoga practice. Unlike commercial PVC-based yoga mats produced using chemicals, our mat uses banana/cotton blends with natural finishing. The product achieves the necessary thickness and stiffness without toxic substances, embodying pure sustainability. The project highlights banana fiber's great, untapped potential as a sustainable resource for textiles. The chosen blends, herbal dyeing, and printing showcase an eco-driven path forward. The B40C60 blend is optimal, offering quality, aroma, and comfort as well as prospects for other sustainable products beyond yoga mats. Finally, the textile industry's environmental footprint can be dramatically reduced by adopting sustainable fibers and processes like those demonstrated here. Extending textile product lifespans and improving resource efficiency can fulfill a significant portion of global material demand by 2030. This research opens doors for sustainable alternatives in home textiles such as cushion covers, table mats, and more, replacing harmful plastics and synthetics for a healthier planet. Thank you for this opportunity to present at the 8th International Scientific Conference on Contemporary Trends and Innovations in the Textile Industry. It is a privilege to share insights on sustainable textile innovation, and I sincerely appreciate the chance to be part of this distinguished gathering with esteemed colleagues and experts.